Welcome to the short video about Doolittle method and Crout method. We will see how we can do them easily. So LE factorization is a method in which we solve a linear system and we try to factorize A into two triangular matrices L and U. So the problem is how can we can write A in L and U, where L is lower triangular and U is upper triangular. To have this, we simply use the matrix multiplication, and we know that if A is the product of B and C, then any element of A, which is PQ element, it can be obtained by multiplying P row of B matrix with Q column of C matrix. And then there is a concept of triangular matrices. This is the form of lower triangular matrix L, and this is the form of upper triangular matrix U. You can see that in case of L, we will be finding only those values of Li j where I is greater than or equal to j, and in case of U, will be interesting to find I greater than or equal to j. In Doolittle method, we have man diagonal of L matrix as 1, and it is a lower matrix, whereas U is an upper triangular matrix. So in case of L, we have to find I greater than J, where Lii is equal to 1. In case of U, we need to find Lij equal to 1. Whereas in Crout's method, it's totally opposite to the Doolittle method. U matrix has man diagonal 1, so we'll be having the strict inequality over here. So this is what we do for a triangular matrix and matrix multiplication. You know that if I want to compute ij component where A is the product of L and U, then I have to multiply row of ith row of L matrix with the jth column of U matrix. So if I want to get A 3 4, I need to multiply third row of L matrix with fourth column of U matrix. So you can see that third column of a triangular matrix will have 3 1, 3 2, and 3 3 indices, whereas the four column of U will have 1 4, 2 4, 3 4, and 4 4. And to make it a column matrix, I am using this T symbol over here. So when I multiply it, I get how many terms? I get 3 terms, which is the minimum of 3 and 4. In case when I multiplied sixth row of L with fourth column, I will get minimum of these number of terms on the same basis. So when it is Doolittle method, I know that Lii is 1 when I have to multiply third row of L, means L31, L32, and L33. L33 would be 1, and it is there will be 4 entries of the column that would be multiplied. So there are only 3 non-zero entries, so I will get only 3 term, with last term is U34 multiplied with 1. We can see that here 3 and 4, the 3 is the minimum thing. So and I means I index is minimum, we will calculate U. So when ij between ij, if I is minimum, we compute U, and it can be computed with the help of multiplying ith row with jth column. We simply multiply ith row with jth column, and then we'll see what uh, small manipulation we can do. So when it is Crout method, you can see in Crout method, man diagonal of U is 1 1. So when I multiplied 3 with 4, a third row with fourth column, so I'll get L33 and U34. L33 is not 1 in this case. So as it is 3 4, so we will be computing u 3 4. So I have to divide l 3 3 over here, but this calculation can be done if we just multiply these two row of third row of l and fourth column of l, and then we can see what manipulation can be done. We can see when in Doolittle method we multiplied a64, where 6 first index is more than the second index. In this case, I is greater than j case, so we will computing L. In this case, you can see that there are lesser number of entries are in u, so you will be having a product of L and u uh, in elements. So when we'll want to calculate L, we have to divide U with something. So that we will see in our next slides. So this is the Crout method. Will UIA is 1. When UIA 1, I want to multiply L A. I want to get A64. So it means that U44 will be 1, and I will left with L464. That's why we do not divide anything when we calculate L64. So what I want to tell you over here that first we'll find row first row in Doolittle method, then first column, then second row of U, second column of L, and so on. So this is the procedure that we generally follow. Whereas in case of Kraut's method, we try to find first column of L, then first row of U, second column of L, second column of U, and so on. So this is the procedure to calculate LU factorization in Crowd's method. So let's do an example to see whether how simply we can get LU factorization if we use the approach of row and column multiplication. We can simply get U11, U12, U13 as in case of Doolittle method uh, as the first row, and we can easily compute L21, L um, 3 1. So what we can see over here, you can see here two matrices are given where with some entries are known. As you know, we compute column row in Doolittle method first and then column. So I have done it for some cases, and now I want to compute second row, second column. So second row, second column means A22, which is equal to 3 here. So this is equal to 3. It will be given as L second row and U second column. So this is how I can do. So L21, U12 plus L22, U22. So in this case, we will have 0 for our next entries. So this is 1 as we are in Doolittle method, and in Doolittle method L has man diagonal 1. So I will be having 3 equal to L to 1, which will be over there if I follow the sequence. So 5 by 3 into 2 by U12 is 4. So U plus U22. So which implies U22 is equal to 3 minus 20 by 3, or it may be equal to minus 11 by 3. If I want to compute A22 for the case where I have a Crout method, so I have to do it second row of L, second column of U, so it will be U L21 U12 plus L22 U22. In this case, this would be 1. So I will be having 3. 2 1 in this case is already calculated, which is 5, and 1 2 is 4 by 3 plus L22. So from A22, in Doolittle method we calculate U22, while in case of Crout method from A22 we calculate L22, and it is by chance the values are the same, because when I do L22, I'm going to multiply 3 minus 20 by 3. I'm going to get minus 11 by 3. So what next? I can write this value over here, that U22 is equal to minus 11 by 3, and similarly I can write the value for the Crout's method, that L22 is equal to minus 11 by 3. Now what next element would be, in case of Doolittle method, it would be A23. So I need to multiply L second row and second row and U third column. So it will give me L21 U13 plus L22 U23, and next entry would be 0, because U23 is 0. So this is 1 in Doolittle method. This is the entry which I know, it is 5 by 3. A23 is equal to 2, so U13 is also known. If I follow the sequence, then the things would be known to me, and U23 would be 2 plus 5 by 3. It will be 11 by 3 in this case. But what is in this case? In this case, I have to complete row, and I need to calculate this element of, I have to utilize this element of A. So it is A32, means I need to multiply a third row with second column. So it will be L31 U12 plus L32 U22, and plus 0, because U32 would be 0. I must remember the form of the matrix or triangular matrix I am trying to do. So A32 is 1, L31 I must have calculated it if I am following the rule. So U12 is 4 by 3, and in this case U11 would be 1. So L32 that I need to calculate. This 32 implies that I is greater than J. So I must calculate L. So 1 plus 4 by 3 is equal to L32, which if I simplify it, I'm going to get 7 by 3. So in this way, we can complete the things. So now you can see how we can multiply and simplify. So value factorization is very easy if we remember that we can multiply pth row and qth column to get PQ entry, and we must remember that I is greater than j means Lij, and I less than j mean I am calculating Uij. For Doolittle method, I must remember that Lii is equal to 1, and for Crout method, Uii is equal to 1. So in this way, we can compute all entries Lij and Uij very easily, and we can complete LU factorization of A very conveniently. Thank you very much.